Is that first chapter of your math syllabus giving you a hard time? Well, don't worry about it. We're about to make HCF and LCM totally, completely clear in this explainer. Let's get right into it. Okay, let's kick things off with a little puzzle. You've got two numbers, 84 and 70. So what's the biggest number you can think of that divides both of them perfectly, with no remainder? And on the flip side, what's the smallest number that both 84 and 70 can fit into? Just hang on to those questions, because we are absolutely going to find the answers. Now, before we can go and crack that puzzle, we got to get the basics down. And it all boils down to two really simple words: factors and multiples. Trust me, once you nail this part, everything else just kind of falls into place. So let's just take a super simple number, like 8. Its factors are all the numbers that can divide into it cleanly. So, 1, 2, 4, and 8 itself. Easy enough. Now, its multiples are the numbers that 8 divides into, which is really just its times table, right? 8, 16, 24, and so on forever. So think of it this way. Factors are usually smaller, and multiples are always bigger. All right, on to our first big term, HCF. That stands for highest common factor. And you know what? The name tells you exactly what to do. You find all the factors that are common between your numbers, and then you just pick the single highest one. That's it. It's the biggest number that's a factor of all of them. And then we've got its partner, LCM, or lowest common multiple. And you guessed it, the name is the key here, too. You look at the list of multiples for your numbers, find the ones they have in common, and then you pick the absolute lowest one. It's literally the very first number you'll find in all of their times tables. Okay, so how are we supposed to find the HCF and LCM for bigger numbers like our 84 and 70? I mean, who wants to write out endless lists of factors and multiples? Nobody. So we need a tool. Actually, it's more like a super tool. And that tool is prime numbers. Here's the cool thing. Every number out there is either a prime number itself or it's built by multiplying a bunch of prime numbers together. They're like these fundamental building blocks. It's kind of like a number's unique DNA, a secret code that tells you what it's made of. So what exactly makes a number prime? It's simple. It has to have exactly two factors, just one and itself. That's the only rule. So numbers like 2, 3, 5, 7, they're all prime. But a number like 4, nope, because it can be divided by 1, 2, and 4. See? It's got too many factors. So now we have our super tool. Let's put it to work. This whole process is called prime factorization, and it's how we're going to break down our puzzle numbers into their secret DNA to find both the HCF and the LCM, nice and easy. It's really just a simple 3-step method. First step, break down each of your numbers into its prime building blocks. Step 2, for the HCF, you only look at the prime factors they have in common, and you pick their lowest power. Then for step 3, the LCM, you look at all the different prime factors involved from all the numbers, and you pick their highest power. Let's see how it works. Okay, here we go. We've got 84 and 70 broken down. Now for the HCF, what prime factors do they have in common? Looks like 2 and 7. We take the lowest power of each, which is just 2 to the power of 1 and 7 to the power of 1. Multiply them together, and boom, we get 14. Now for the LCM. We need the highest power of all the factors involved. So that's 2 squared, 3, 5, and 7. Multiply all of those together, and you get 420. And there you have it. Puzzle solved. The biggest number that divides both 84 and 70 is 14, and the smallest number they both fit into is 420. See? The method makes it so much simpler. So now that you've totally mastered the main method, it is time for a pro tip. There's this really cool relationship between HCF and LCM that can be an absolute game changer, a massive time saver. Check this out. For any two numbers, if you multiply their HCF and their LCM together, you get the exact same answer as multiplying the two original numbers themselves. It's an awesome shortcut. If you happen to know any 3 of these values, you can always figure out the 4th one. But you gotta be careful. This amazing little trick has one very, very important rule you just can't forget. It only works for a specific number of, well, numbers. 2. That's it. This formula is your best friend when you're dealing with a pair of numbers, but the moment you try it with 3 or more, it doesn't work. This is a classic exam trap, so please burn this rule into your brain. HCF times LCM equals the product, but only for 2 numbers. All right, let's do a quick recap and lock in the most important things you need to remember from all this. Okay, first, HCF is the biggest number that divides into your numbers. Second, LCM is the smallest number they both divide into. Third, your secret weapon, your master tool for finding both of them, is prime factorization. And finally, don't you forget that awesome shortcut for two numbers. HCF times LCM equals their product. And really, why does any of this matter? Well, because HCF and LCM aren't just stuck in your textbook. This is the math used to schedule train routes so they all meet up at the right station at the right time. It's even used to create the complex encryption that keeps all your data safe online. It's pretty much the hidden logic of our world. So next time you see some kind of complex pattern out there, you gotta wonder, could prime numbers be the secret key?